Dear colleagues, dear conference organizers, thank you for the opportunity to present the report. Dear colleagues, we bring to your attention a report on this topic, an IoT system based on open APIs and geolocation for human health data analysis. The authors of the study are Klochko, Fedorets, Mazur, Liulko. At this stage of the development of Internet of Things technologies, more and more attention is paid to the development of healthcare applications in IoT systems, as they provide an opportunity to remotely monitor the state of human health in real time. Demand of professional use of IoT systems for real-time health monitoring in relation to environmental conditions, including environmental risks, is present in many fields of activity, science, and education. There is an urgent need to develop and implement such IoT systems that would expand the possibilities of air monitoring for the present of origin in the environment and accordingly present data on the level of their concentration in representative and user-friendly formats. Monitoring of origins of plant origin, which are represented by the pollen of some plants, is important in this regard. The purpose of the research is to design and implement an IoT system based on open APIs and geolocation of human health data analysis. In the process of work, research methods were used: analysis, synthesis, methods of system analysis, methods of communication theory, development of a system that supports Internet of Things technologies, modeling using the Unified Modeling Language (UML), in particular to build a UML diagram of precedence, mathematical modeling, computer modeling, monitoring, and data analysis. Cloud computing, OpenAPI, and wireless access methods were used to solve the tasks. The methods of combining devices based on open APIs using smart gadgets and meteorological disks, a smartphone with wireless technologies was proposed. It has been used to track and analyze data related to human health anywhere at any time, interfacing with meteorological data to provide operational data, warnings, in real time of the likely presence of threats of human health. The study considered two main groups of environmental factors as elements of the environmental system that influence the human body. One, abiotic, temperature, humidity, solar radiation, atmospheric pressure, chemical, air pollution, etc. Two, biotic, pollen. Meteorological geographic information system (natural blue) was used to quantify environmental factors using open APIs. In accordance with the research goal, the task was set to develop and implement a new anthropo-digital system for preserving human health by building an IoT system based on open APIs for monitoring and analysis data related to human health, taking into account geolocation. For this purpose, it was planned to use smart gadgets, fitness graphs, and smartphone, and meteorological geographic information system. The software application based on open APIs provides collection and analysis of sensor data using smart gadgets. The software application based on open APIs provides 1. Collection and analysis of sensor data using smart gadgets. 2. Real-time data process analysis of environmental factors of order to identify the risk of human health. 3. Generation of warning message to the user's mobile phone. This system implements a warning about the threat of a person being in an environment with polluted air. The UML diagram of precedence described to IoT system at the conceptual level and precedence a scheme of relation between the actors and the precedents that characterize the capabilities of the IoT system. 1. Relative indicators of heart rate, number of steps, and distance covered. 2. Obtain data on the state of external environment. Monitoring of geolocation sensor data with 3. 4. Processing and analysis of the state of the external environment based on geolocation data in order to detect threats of human health. 5. Receiving warning signals about threats to human health. 6. Receiving a notification about actions aimed at preserving health. Thus, the architecture of the IoT system proposed by using is a network mode. It is assumed the following are integrated in this model. Smart gadget. We use the Apple Watch for fitness tracker as a smart gadget. Smartphone. Scala-independent integrated meteorological geoinformation system. Cloud service used to host a software application for monitoring and data analysis. Also, for meteorological data monitoring and analysis, we have developed a software application based on open APIs, which prepares the data of the meteorological geoinformation system. Data analysis is carried out to provide real-time operational warning about the probable presence of threats to human health. The quantitative assessment of environmental factors is carried out automatically online, taking into account human geolocation data and data on the state of the surrounding environment, which can be obtained using open APIs of geoinformation system. A software application based on open APIs that analyzes sensor data and geolocation data of smart gadgets and meteorological geoinformation system, analyzes them, and generates messages about possible threats to human health, developed in the Python programming language. In order to evaluate performance, we conducted functional testing of the IoT system. Performance of the IoT system was tested on various test data: geographic coordinates, state of air pollution, concentration of pollen in the air. As a result of the test, it was accessed. The IoT system returns the expected result in the response of the specific entered parameter. The system showed a high efficiency of 100 on the specific test geographic data. Various parameters of the air pollution state, including the limit parameters. As a result of testing the IoT system according to the air quality index, it was determined that the MG's MeteoBlue system shows only a background index. This IoT system does not define a roadside or traffic index. Therefore, as a result, it is tested near highways. It was found that the system is not effective in use. For the purpose of testing the system, data obtained previously form as a similar Apple Watch for fitness trackers, which determines a person's geolocation was used. If there is pollen in the air, pollen grass, pollen birch, pollen olive, the system issues a message about these dangers, indicating the level of pollen concentration in the air. The concentration of pollen in the air can be increased by the environment. Also, the pollen become more allergic if their air is polluted. The use of the developed IoT system can have preventive and pretend cases therapeutic value. This is necessary for the prevention of pathologies related to the state of the external environment, in the particular, the presence and level of the concentration of substances that can be allergens. It is important to use the developed IoT system for the prevention of allergic diseases, including, first of all, pollution, as well as other pathologies in which an allergic component is present. Among such disorders with an allergic component is signal out bronchial asthma. Thus, bronchial asthma is present not only as a medical, but also as an ecological problem. The important preventive aspect of which can be solved by the developed IoT system. The recommended scales of the Air Quality Index and the European Common Air Quality Index were used to generate the message. According to the value of the air quality index, the system issues a message about the threat to human health and recommendation for the action in this situation. In conclusion, the developed application based on open APIs using smart gadgets and meteorological gears in the process of work generates a message about the dangers of human health related to the presence of pollen in the air, pollen grass, pollen birch, pollen olive, indicating its level concentration in the air. The presence of air quality problems if the air quality indicators exceed the permissible standards. Functional testing of the IoT system was conducted of various test data: geographical coordinate, state of air pollution, concentration of pollen in the air. Based on the given test geographic data, various parameters of the state of air pollution put in the limit parameters. The system showed high efficiency. However, as a result of testing the IoT system according to the air quality index, it was determined that the MG's metal blue system shows as a background index, therefore the system is not effective in use along with these rules. IoT system for tracking data related to human health is aimed at preventing the problem of negative effects of environmental factors on human health, which is implemented by generating warning signals about the possible risks and the reminders to task actions aimed at preserving health. The implementation of this IoT system has significant methodological and technological potential, which can be used to improve the effectiveness of healthcare both in extreme conditions and in conditions of sustainable existence. First of all, it is relevant during and after the COVID-19 parametric. This development is significant for improving the quality of life. The system developed by use can also be considered as one of the ways of introducing innovations in the field of healthcare. Both theoretical and practical results, conclusions, proposals, and recommendations formulated in the study can be used to improve and increase the effectiveness of the human healthcare system. For example, during and after the COVID-19 pandemic, in the educational process of training and reminding of teachers of informatics, physical, cultural, ecological, health basic, doctors, rehabilitation teachers. In practice, in technologies of rehabilitation, medicine, ecology. In the scientific research in this topic. As one of the ways of introduction innovating in the IT sphere and the sphere of healthcare in everyday life. Dear colleagues, the report is over. Thank you for your attention.